In this demo, we're going to show a couple of the different image processing tasks that are available in DAX. Basically going to kind of make our own source detect algorithm. It's not a very good one, but it's just to demonstrate what's going on. So here I've got an image loaded. I'm going to change the bin size just to make things go faster for the demo. Make the bin size a little smaller, and I just want to energy. Okay. So I'm going to start by just doing a simple adaptive smooth. I'm going to use a cone again. It's a little bit faster. Linear. So it's going to get at least 16 counts under the convolution kernel. Minimum radius 0.5, maximum 15. And you can see it's running the chow DM image adapt tool. Okay, and it's going to tell me where the file is located. Now with this, I want to estimate the background. There is a chow thread that describes how to do this using a nonlinear filter. It's a so-called median ring. So I'm going to look for I'm going to compute the median value in an annulus around each pixel, and I'm going to use that as a background estimator. So again, this is where the output file is, and this is not my estimate of the background. You're going to say it looks very noisy, and but look at the range of the pixel values. They're very, very small. If I were to frame, match, scale, and limits, oops, min max, frame, match, scale, and limits, you see that the background is, relatively flat. Now what I want to do is I want to subtract the background from the smooth image. Well, there's now a task that lets me do this. We now have a calculator in here, and what I want to do is I want to subtract this frame from the previous frame. So I have two options. I can subtract the previous frame from the current, which isn't what I want. I want this one, which is subtract the current frame from the previous. And there it is. We can look at the pixel values. Or we can actually use the analysis histogram pixel values. Axis y log. You can see that they're plus and minus. To this, we're going to now apply a threshold, because we subtracted the background, so now we want everything above the background. So I'm just going to pick an arbitrary value. I'm going to say, I don't know, 1.25. And this is counts, so it's net counts. And anything below that I'm going to set to 0. Okay. And we now have this image where you can now see the pixel values are largely 0. And now I can actually label each one of these individual sources using a task called blob. So it's going to blob together everything with pixel values greater than 1. And you can kind of see this here. This guy we can do linear, and I can now actually do single frame. It's kind of hard to see here, so I'm actually going to change the color map to use one of our custom color maps, basically a random color. And so you can kind of see the colors are now random, and I can actually change the background. Instead of being white, I can go black. So you can now see each of the individual sources. What you do with them from here, that's a different story, but just kind of demonstrate the different analysis tools.